Hi, welcome back. So next up we have Xin Liu. Xin leads Azure Network Platform PM team. She is responsible for evolving the network infrastructure with the latest hardware, software technology, that is SONiC, building management system and health system to operate the network with extensive scale. Shin has been working in the cloud space for 10 years and has been a big champion of open source technologies. She has been leading the SONiC community since its very early stage, building a rich ecosystem to benefit broad user community. She has a bachelor's degree in electrical engineering and a PhD in computer science. She is a mentor of female engineers and graduate students and love to grow more of them in the high-tech area. Shin, welcome and look forward to your exciting talk.
Thank you so
away.
much. Yeah. Can you guys hear me?
Yes.
Yeah. First of all, thank you, Guru, for the nice intro. This is Xin from Microsoft. I'm very happy to be here. Today, I would like to share the story how SONiC and SONiC Dash expedite and amplify the impact of programmable network hardware. SONiC has been there around for 6 years. It's no stranger for most of you. But let me still give a very quick brief for the people who might not know before I go deeper into it. SONiC is stand for Software for Open Networking in the Cloud. It is a Debian Linux-based network operating system supported by more than 100 switch platforms and all major ASICs. It is actually, to be short, it is all about disaggregation and rich choices. So you can see that using a SI, the switch abstraction interface, it unified the control functions to different hardwares. It enabled the OS to reach the hardware agnostic capability. It helps to disaggregate the hardware from the software. And it also disaggregated the software component from each other through containers, through Docker containers. This helps each functionality component can be developed by different partners and also evolve differently, easy to extend to support the new functionalities and new hardware. It has been widely adopted by the industry, cloud provider, enterprise, and then start to extend to some of the like technical space. It has been predicted by the industry research that it has the potential to become the Linux for networking. The latest news about SONiC is it's recently joined the Linux Foundation, now serving as a bridge between OCP and Linux Foundation, and also a tie between the software and hardware. SONiC actually evolves in many ways, very rapidly since it coming into being. Today, we are going to focus in the programmability areas. Its relationship evolves with programmability, evolved from the supporting to leading the acceleration role. At very early stage, we have SI, Flex, which enable SONiC to be able to build on silicons, no matter it is a fixed pipeline or programmable, like ASIC. It also allows the SI implementation to be written either in P4 or other language that any silicon vendor choose. So it gives choices for the developers to implement it. Then since last year, at the end of last year, we launched PINS integration to SONiC. The actually collaboration started a long time before that. PINS is also no stranger. PINS is this ONF is the home for PINS. It's a great, very powerful architect that stands for P4 Integrated Network Stack. So basically, fundamentally, what does it do? It enables a hybrid control plane which enable a user either use the switch box to decide the route, decide the network functionalities, serve as a smart or intelligence state as in the switch itself, or it allows that the SDN controlled ASIC will this a thin switch box. It is built on top of P4 runtime to define the flexible data pipeline to write it to side and control the ASIC. And it uses a familiar interface using gRPC to allow the control. So PINs is still evolving in the SONiC community, that we will continue doing, adding more tests, error reporting, detection, and adding more configuration capabilities to PINs. Yeah. With that, let me come to this. What's next? Most recently, we have seen a lot of hardware emerging. These hardwares are powerful, they are smart, they are programmable. So they have extent. So just to name a few capabilities, for example, the connectivity of this type of smart programmable like network device can go up to 400 gig, and in 1 or 2 years, it can even go to 800 gig. It can serve up to 200 million packets per second. The technology can evolve from 16 nanometers to 7 nanometers, now ends with 5 nanometers, which reduce much less power than the other technology. They are P4 programmable. And in terms of connectivity connections, some of these chips that are like having tens of millions of flow, can support tens of millions of flow at millions of connection per second networking capability. So we call this there's a class of devices, DPU, data process unit, or IPU, infrastructure process unit, or smart NIC. So in the following conversation or talk, for the convenience, I'm going to call them all as DPU. They are not only limited to network functionalities, they also have very powerful security functionalities. For example, to support millions of policies, roles can do up to 400 gigabits crypto encryption, decryption. Also can accelerate the IOPS for storage scenarios, like up to 40 million IOPS per second. These are a bunch of the most mentioned that DPU, IPU, the smart programmable networking device recently in the news. So then we have seen this powerful hardware in single unit. We think from the user point of view, we were thinking, what's the benefit we can get out of it? It's very apparent that because of the very powerful hardware capability, we see a lot of use cases that can accelerate our connectivities, encryptions, rules for very high performance like applications. We also see the use case that it offload the CPU to let all these functionalities to be done by the DPU or IPU, so that we can release the valuable CPU time cycle for the applications. Because this device, if added to any server or switch, is isolated. So we can see that it will bring more safety through security isolation. So, but as a service provider, as an enterprise network builder, are those all that we consider, and when we need to build end-to-end scenarios, actually, as a matter of fact, that we have to think more like than one unit, one single unit. We need to think when we build this network, leverage this new hardware. How do we manage it? How do we evolve it from generation to generation, right? How do we introduce diversities so that we can avoid supply chain shortage, or supply chain shortage have multi-sourcing of different hardwares, so that the solution is sustainable for long term? And when we introduce different hardware to accelerate, can they be interoperability? Can they interop? Yeah. And also when we think about it, there's many different formats. We have DPUs, IPUs, which can build into a server. We can have that they build into appliance. They could build into a smart switch. What's the best solution for your scenarios? And do we understand the application deeply so that we can maximize the capability of all these very powerful hardware units? So with that, we are going to introduce our solution. It's called DASH. It stands for Disaggregate API for SONiC host. It's based on SONiC. It is actually an open source project, open source forum. We meant to achieve like 10 to 100% times, 10 to 100 times per scale than what's offered in today's cloud and enterprise. By that, we would like to maximize the innovations, core switch, DPUs, IPUs in a complementary manner. Well, 1 + 1 not only bigger than 2, but even bigger than 3. How we could do that? Dash consists of 4 components. First, that we have, you already see that we have the hardware component. We have the smart, powerful, programmable, very capable network devices already being in the industry. Second, in the community, we have an ecosystem. We have cloud providers. We have hardware suppliers and experts. We have solution providers and user of enterprise and 5G. We built this open source community. In the open source community, we defined a behavior model based on P4. We defined the standard APIs and tests to control the quality. I will come to touch this part and the last part in the following talk. The last but not least is based on SONiC, which has already established the ecosystem. It's a matured open source community. It's perfect for disaggregation, and its extensibility via Docker enable us to support the DPU, IPU, or smart switch easily. So with these 4 pieces, let's take a look to see how how Dash help us to facilitate, to maximize that our capability of using the smart programmable DPUs, IPUs for scenarios that for an end-to-end solution. So let me use state in the networking instead of security and storage as an example. We have, as you can see, that we have a bunch of very powerful hardware devices, have strong beefed up network capabilities. As a user, for example, a cloud provider, we have applications. We have the most common SDN capabilities, and also other applications. Using SDN as an example, it is a terminology that is very well known. However, there is never a very published behaviors or standard how it is implemented. It is actually a more proprietary solution for each different owners, cloud, enterprise, how to look into the packet, what's the sequence of defined all these events, is actually not very well known and not very well documented. In this case, if we want to build solution using these smart devices, hardware, network hardware, then if there is no community, then highly likely we will see the situation is each one working with dedicated hardware vendors to have a customized solutions to accelerate, to optimize for the solutions. So that's actually not what we wanted. In this case, that the hardware, right, with the capability with the capability, they can do a few times of acceleration, performance improvement. What this SONiC Dash community is doing is actually publish the SDN requirement, function requirement, and the behavior model. Microsoft, as leading the community, is the first one to publish our SDN secret, the function requirement, how it behaves, what's the sequence, and using P4, turn it into P4-based behavior model and make it very well known. With this, actually the hardware suppliers able to understand this sequence, able to understand the source behind it, they are able to use the hardware to accelerate it, to be able to improve the benefit from several times to 10 times or 100 times, like in terms of performance, connectivity, CPS, PPS, you name it. So as you can see that D-Dash actually is meant to complement the hardware capability to enable that hardware to be able to optimize for targeted accelerations. Next, that's not the end. We also found using SONiC, we also noticed the importance of having northbound and southbound API standard, how important it is. With southbound, APIs, by southbound, I mean the control, the OS, the software, how it talks to the hardware. By standardize that enables users to have to be hardware agnostic. It enables the users to have more choices. Also enable more users to adopt the technology so that it does not need to worry about knocking with a hardware vendor. The northbound, I meant from the OS to the user side. That in the community, we defined use GMMI, Young model, a very familiar, industry familiar, the standard to communicate, the format of communicate and format of the data, data definition. This enables us to achieve the manageability. No matter what type of solution we build, we don't need to reinvent the wheel to redo the management tooling and system. So by this, I'm already showing the second capability of Dash. Looking into, you might ask how easy it is to support the new hardware, the smart, programmable, powerful DPU, IPU, and you name it, the class of this new hardware. So it turns out this is an eye chart. This is a SONiC architect. For people already familiar with that, it's simple to understand. The top row means the containers of applications. We put different application, BGP, TeamD, telemetry, each one into a container. The middle row is the brain of the system. It consists of orchestration agent to coordinate all the actions from the application containers. It has a database which accepts all the rules from the application and orchestrated by the SWSS and then write to the ASIC. The bottom are the network like hardwares. So to introduce the support of new DPU, IPU, smart SONiC, you name it, you introduce first a hardware driver at the bottom. Then add a driver, the SAI APIs support for this hardware into syncd container. Last but not least is to enable the northbound connectivity. Northbound connectivity, implement the GMAI like YARN model to support the communication from the hardware, from the north to the user. So you can see that even though with this containerized design of SONiC, it is actually very easy to extend to support new hardware, lightweight. So the last but not least, I would like also to spend some time to discuss what is the right solution. We have seen that we could build the smart devices into each server. We could also build it aggregated as a appliance to connect to the switches, like the TOR, which sits right above the server. We can also build the smart devices into smart switch itself, become a switch which has CPU, DPU, or IPU, like with ASIC, to do the functionality as one single box. This box could sit also in different areas, could be on top of the server, could be even higher layer that even more aggregated with the traffic. The answer actually is it's all about choice, and it's all about your application. We have seen different scenarios where it makes sense to sit with the server, which each server, if you have very heavy applications like rules to encrypt, that it could sit actually with each server. It could also be aggregated or multiplexed as appliance attached to the TOR or smart switch. This is in our case that we have the top 5. It's not all the application has very high demand of CPS, PPS. We have top 5, like top 5 offenders of applications which demand a lot of connectivities, very fast, like CPS, a lot of flows. In this case, you could have the smart device aggregated as an appliance to attach to the TOR, or to build into the TOR that able to share with all the servers. In this way, you can see that we balance between the optimization, acceleration of the traffic, as well as the cost and the power consumption. So a short answer is there is no fixed solution. It's your choice. But the message I'm trying to give is, no matter which solution you are, we see that SONiC-based Dash is easy to run on a single card, on the appliance, or as a smart switch that can enable you not to change the software, the management system, even if you need to choose different technologies. So these are the members in the Dash group. As you can see, the most of the smart device companies are very active there, including we have the major ASIC, major NIC companies, platform switch network platform companies, as well as a few solution providers. But we would like invite you to come to join us, to be part of this journey, to facilitate and to maximize the use of the programmable smart hardware devices. So how about where we are? Looking forward, what we are looking. So today, we are working in the areas of SDNs, VNet peering, private tunnel, high availability, etc. SDN scenarios. We start with SDN scenarios. Start with the cloud operation, cloud infrastructure operations. The purpose there is offload from CPU and achieve high performance, high scalability. We see that it also have a great need in the load balancer, encryption, 5G edge area. That we could in the application is asking for a large number of very fast encryption, handle many of the load balancing workload traffic. In the future, we also see that it can easily extend to the storage, AI, or the offloading, even offloading not only CPU but the GPU, like workload, all the networking, security, or storage functionality, give it to DPU or IPU. Let the GPU do the thing that it is intended to do. With that, I'm going to summarize today's talk and ending this very soon. The takeaways are: Dash is an open source program that empowers limitless networking with 10 to 100 times of speed and scale improvement. How it's achieved that? Actually, it's achieved by a hybrid model. It uses software to define the behavior, make it very clearly defined and understood by everyone. And this enables the maximum of hardware acceleration and optimization. It is built on top of SONiC, which is battle-tested OS, able to run both on the card, on appliance, on the switches, and very easy to extend to support the smart programmable device. Last but not least, we see a lot of opportunities. Tons of user cases could be optimized. There's rich choices. All the hardware are evolving, right, with more and more powerful capabilities, and there's ecosystem. This ecosystem, rich ecosystem, with standardization, it will enable that more opportunities for adoption and for business. This is a contact of community. We have a Dash community with the GitHub, with its mailing list listed together with SONiC GitHub and mailing list. We welcome, we call for participation for everyone. Please join us. Please join us in this journey to amplify, to facilitate and maximize the use of the smart device and very powerful network. Actually, this is a very exciting area and a lot of innovations ahead. Please use it, try it, and come to discuss the features, your applications, and your requirements. Even test the train or test it, raise questions that together, I think we are looking forward to a very very beautiful, also very exciting world. Yeah. With that, thanks everyone for your time.
So thank you, Shin, for a great talk. As always, very impactful work. So first of all, I want to take the opportunity to also congratulate you on all the progress and successes you have had with SONiC. And this new project Dash is also very timely and likely to be very impactful. There are a couple of questions and a few things I would like to clarify. And so I think when we talk about SONiC, let's go to SONiC first, and then we'll come to Dash. Okay. Sure. So there are a couple of questions that are related to SONiC. So I think when you talk about SONiC and SI and giving the hardware agnostic part to it, there is two sides of a question. One question is there really, are there good examples of SONiC achieving the hardware agnosticness where either a cloud operator or a customer or the user was able to seamlessly transition from using one silicon to another silicon because of the SI interface and not have to do anything because it was based on the standard SI? Are there good examples of that hardware agnosticness and people able to do that in a seamless fashion?
Yeah, that's a very good question. As a matter of fact, Microsoft itself is an example. Sorry that I cannot release our vendors, our hardware suppliers' name, right? But it's true that we use at least the 3 different types, like in one row, for example, in one row of the data center tier 0, tier 1, we use at least the 3 different ASIC vendors. Like ASIC, like silicon suppliers like ASIC, right? We are able to run one piece of OS on top of it. The same that on our T2 above the chassis, we are also using at least 2 silicon vendors, but we are running same like software on top of it. So I believe other companies might also see the same, but I will let them to talk about it. But for us, we already have seen the benefits of hopping between like silicon suppliers that we don't need to change that the OS on top of it.
And the flip side of that question, and again, this is a very standard question, I'm sure you've answered 100 times already. So, but I just want to make sure that I represent the audience here well, is once you standardize the SI, it limits your ability to exploit the silicon differentiation or the silicon capabilities that they offer. And so if there are not good examples that people are able to use multiple silicon, I mean, Microsoft is one good example, hopefully there are more. But then the flip side of that is you're not able to exploit the silicon capabilities if you standardize on one interface. So how have you coped with that in the SONiC community?
Yeah, that's another very good question. Actually, we see it in 2 ways. One is in one way that the SI community is actually working very hard, right? People come to bring their scenarios. These scenarios not only coming from SONiC, but maybe come from FBOSS, coming from other applications that needs to use SI. So that the SI application at this or no SI APIs actually has been growing like exponentially. That is one. The second one, what you said is exactly true, that there are capabilities, the silicon differentiators, right, that we do allow that about to happen and to be used. It's called the SI extension, which allow, for example, before Tofino, right, it has in-band telemetry. Right, we like defined extension, SI extension to allow that different capabilities. Silicon has different capabilities also to be exposed from the SI extensions, so that at the end we want to benefit users, not too tied to the standard process, right? But we want to standard as much as possible, but also allow the fast evolution.
Yeah, I think that a faster evolution is where maybe people may debate that, but I think maybe we'll take it offline, because how fast you can introduce the SI extensions and how all of that. So, but anyway, so I guess coming back to Dash, couple of questions on Dash. So again, a great idea and makes a lot of sense and very timely as well. Tell me, why is Dash really tied to SONiC, or Dash can be used independent of SONiC as well? Because if all the motivation and how you are going about it, it could be used independent of SONiC as well. Is that true, or you think they are very closely tied?
Very good question. Theoretically, purely theoretically, I would say that it can be used independent of SONiC, right? Because you see that we are defining the behavior model of defined applications, right? Expose it and standardize it, make it very well known by the implementation of the hardware suppliers and also other people who would like to optimize it. So that is known using P4 and the application, as you can see, that how to control the hardware and northbound, right? It can be lift and shift. So this is true. But why it's built on SONiC, right? We have seen it in different ways. That first of all, to operate a cloud, we have a lot of operations. We have a lot of requirement. For example, security requirement that we are required to patch any vulnerabilities, right? And security risk, we have to do it very fast and then cost the fleet. So that so when we like do that, we need we cannot avoid hardware diversity, right? Because of supply chain, because of the avoid single point of failure, right? And or also cherry pick different type of the best technology. Then if introduce too many different variants of the OS control plane, it's very hard to manage. We cannot even achieve that, fix it in a short time and roll it out in a different way. So we see that why it's a win-win to build on top of SONiC is SONiC has been widely adopted, right? And it has the size actually, achieving size standardization is not a simple task. It actually has been evolved for many years. Now we are at the stage that most all the major silicon vendors are supporting that, right, on the major release of their hardware. Also, the community highly overlap. The community has the hardware suppliers, the users, cloud users, the enterprise people, and the solution network device like suppliers and the solution providers. This is a community that highly overlap and already build some foundation that people has common language and common scenarios. That's where I see that the building on top of each other actually amplify and facilitate the progress.
Okay, so I want to understand, you said Dash does the behavior modeling. From the behavior modeling, how do you go to the execution and be able to create API that you can then put it in an execution runtime environment and run it? So maybe I'm missing something. So how do you go from behavior model to the execution and being able to create the runtime? Are there a tool chain that already exists, and is that something that a community can use? And is that part of Dash?
Yeah, actually, for the detail, I have to defer, right, to the engineers. But you are right that when we define the behavior, it is translate at the end, translate automatically to side APIs. And then side API is the way to control it. But that one, I need to do deep research, the translation part.
Okay.
Yeah.
Then another thing is, I'm sure you heard about IPDK. That is something Intel and a group of people are promoting and starting to use as well, that are similar objectives. So how do you see they, whatever, are they competing, or they are complementary, or are they solving different problems?
Very good question, actually. Yes, aware of IPDK. Actually, first thing is, I think we share the same vision, right? We notice the same set of the same set of challenges. How to build, how to enable it from a single powerful hardware device to a full solution, full loaded solution, right, end to end, and evolve from Gen 1 to Gen 2 to Gen 3. Right, that is the same vision and same challenge that we share. And to be frank, I also read about that. Yeah. And Intel actually is one part of the Dash community, right? I see that it's not competing because we learn from each other. The world will always evolve. From everyone has this is open source world, and the beauty is we learn and we evolve together. Even it has some sort of competition only make the world better, right? This is second. Third is actually, I see some difference. At some time, we need to leverage each other. That side has a great tooling, right? A systematic tooling, DBDK, IPDK, SPDK, right? A set of toolings. This part of Dash actually is the strength of Dash is to publish from the user side, from the user people adopted their behavior and their requirement to put it on the table and open the door and to see what's inside. And then it's not only us, right? We would like all the other cloud provider to join us. And in this community, we said we put on the paper, this is our requirement and our sequence of events. We are not dictate the hardware innovation, right? And then the expert of the hardware come to judge what makes the best sense. How do we make use of it, right? How do we support? How do we implement it? A similar model aside, so that I see that from the IPDK part is short of this flavor, that they have good toolings, right? Standard process, that user scenarios we need to connect. User scenarios that we can see that we absolutely see this. The current powerful hardware is way beyond L2, L3. It's extend to L4, L6, L7, right? A rich functionalities. So I see that there is rooms that we collaborate and learn from each other. So this actually is the beginning of journey. I agree with the people that talked on the first day. It's the beginning of journey. Many things can be done.
Okay, very good. So I think that is all I have for now. So thank you again for a wonderful talk and exciting work, of course, on SONiC, but this new effort on Dash. So really appreciate it. So Denise, back to you at this point.
Thank you. Yeah, and thank you for this forum. Yeah, it's fantastic.